So what do we do about computing statistics like those in an unsorted list? Well, plan A, especially for mathematically minded people, might be to sort the list first, which, as we say, reduces the problem to one previously solved. So that is to say, if we know how to sort, we can sort the list and then apply the ideas that we had just been talking about. Now, we're going to be talking more about sorting in a little while, but for now, the important thing to know is that the running time of sorting is big theta of n log n for a list of length n. This is under the comparison model, yada, yada, yada. But the important thing to make note of here is that it's worse than just running through the list, right? You have to run through the list repeatedly, log n times, essentially. And that may be overkill in some cases. If you're interested in a very quick and possibly entertaining introduction to sorting, I've got a music video on the topic called The Sorter, which you can find on YouTube. We'll try to send a link. So plan B is to try to extract the statistic that we're looking for in effectively one scan through the data, so big theta of n. And the time that it takes to zip through the list looking at the values, we should be able to get certainly the min and the max. Turns out we can actually get the median as well, which is a really interesting result. So let's start off with a very straightforward one. The mean of a list, or the average of a list, this is how a statistician might write it. Mu, or the mean, is the sum over all the elements of the list from 0 to n minus 1. We look up the value, we sum them all together, and then we divide by the number of values. It's just the definition of an average. And it's really straightforward to do that in Python as well.